Hey everyone, welcome back to my channel. Have you ever wondered how Siri understands your voice commands, how Google Translate works, or how chatbots like ChatGPT can have conversations with you? Well, all of these amazing technologies are powered by something called natural language processing, or NLP for short. In today's video, we're going to dive deep into the fascinating world of NLP. By the end of this tutorial, you'll understand exactly how computers learn to understand and generate human language. So grab your coffee, hit that subscribe button, and let's get started. So what exactly is natural language processing? Simply put, NLP is a branch of artificial intelligence that focuses on the interaction between computers and human language. It's the technology that enables machines to read, understand, and derive meaning from human languages in a smart and useful way. Think of NLP as the bridge between human communication and computer understanding. Humans speak in complex, nuanced ways. We use slang, idioms, context, and emotions. NLP helps computers navigate this complexity. Some everyday examples of NLP in action include email spam filters that understand whether an email is legitimate or spam, sentiment analysis that determines if a tweet is positive or negative, autocorrect that fixes your typing mistakes, and voice assistants that convert your speech to text and understand your commands. NLP stands on two fundamental pillars: natural language understanding, or NLU, and natural language generation, or NLG. Let me break these down for you. Natural language understanding is about comprehension. It's how computers extract meaning from human text or speech. For example, when you ask Alexa, "What's the weather like today?" NLU helps it understand that you're asking about weather conditions for the current day and location. NLU involves tasks like identifying the intent behind a message, extracting important entities like names, dates, and locations, and understanding the sentiment or emotion expressed. On the other hand, natural language generation is about creation. It's how computers produce human-like text or speech. Think of when ChatGPT writes an essay for you, or when your GPS says, "Turn left in 200 meters. That's NLG in action. NLG involves tasks like text summarization, where a computer reads a long article and creates a short summary, or dialogue generation, where chatbots create appropriate responses to user queries. Now let's talk about the typical NLP workflow. Think of this as a step-by-step recipe that computers follow to process human language. Every NLP application goes through similar stages, and understanding this pipeline is crucial for anyone working in NLP. First up is text normalization and cleaning. Raw text data is often messy. It contains HTML tags, special characters, extra spaces, and inconsistent formatting. This step is like washing vegetables before cooking. We remove unwanted characters, convert everything to lowercase for consistency, and handle special cases like URLs and email addresses. Next is tokenization, breaking text into individual units called tokens. These could be words, sentences, or even characters, depending on your needs. This step is crucial because computers need to understand where one word ends and another begins, something that's easy for humans but challenging for machines. Stop word removal is next. Stop words are common words like the, is, and, or that appear frequently but don't carry much meaning for most NLP tasks. Removing these helps reduce noise and focuses on the meaningful content. However, for some tasks like machine translation, you might want to keep them. Stemming and lemmatization are about reducing words to their root forms. Stemming is like using a rough axe. It chops off prefixes and suffixes. Lemmatization is more like using a precise scalpel. It considers the context and part of speech. For example, running, runs, and ran all relate to the concept of run. This helps computers understand that these are related concepts. Part of speech tagging, or POS tagging, labels each word with its grammatical role: noun, verb, adjective, and so on. This helps computers understand the structure and meaning of sentences. Understanding that run is a verb in "I run daily," but a noun in "that was a good run" is crucial for proper language understanding. Chunking and named entity recognition, or NER, identify important phrases and entities in text. NER assigns names of people, places, organizations, dates, and other significant information. This is incredibly useful for information extraction, content analysis, and building knowledge graphs. Finally, vectorization or embedding converts text into numerical format that computers can work with. After all, computers only understand numbers, not words. There are several approaches. Bag of Words creates a simple count of words. TF-IDF weighs words by their importance, and modern embeddings like Word2Vec and BERT create dense vector representations that capture semantic meaning. These numerical representations allow computers to perform mathematical operations on text, enabling tasks like similarity calculation and machine learning. Now that you understand the pipeline, let's explore some important NLP tasks that you'll encounter in the real world. Text classification includes spam detection, where emails are classified as spam or ham, and sentiment analysis, where reviews are classified as positive, negative, or neutral. Information extraction involves named entity recognition, which we covered earlier, and relation extraction, which identifies relationships between entities. Text generation includes machine translation, like Google Translate, text summarization for creating article summaries, and chatbots that generate conversational responses. Question answering systems like search engines and virtual assistants that can understand questions and provide relevant answers. Text similarity and search help find similar documents, detect plagiarism, and power recommendation systems. Let's talk about the key techniques and models that power modern NLP. The field has evolved dramatically over the years. Traditional methods included rule-based systems with handcrafted rules, statistical methods like naive Bayes and SVM, and early neural networks. The revolution came with deep learning. Recurrent neural networks, or RNNs, could process sequences of text. Long short-term memory networks, or LSTMs, solved the problem of long-term dependencies. But the real game changer was the transformer architecture, introduced in the Attention is All You Need paper. This led to models like BERT, GPT, and T5 that achieve human-level performance on many tasks. The key innovation was the attention mechanism, which allows models to focus on relevant parts of the input when making predictions. It's like highlighting important words in a sentence while reading. For anyone wanting to get started with NLP, here are the essential libraries and tools you should know about. NLTK, or Natural Language Toolkit, is perfect for beginners. It's educational and comes with lots of data sets and tutorials. Spacey is industrial strength and fast. It's great for production applications and has excellent performance. Scikit-learn provides classical machine learning algorithms that work well for many NLP tasks. For deep learning, you have Transformers by Hugging Face, which gives you access to state-of-the-art pre-trained models. TensorFlow and PyTorch are the main deep learning frameworks. These tools make it incredibly easy to get started with NLP, even without deep technical knowledge. Despite all the progress, NLP still faces significant challenges that researchers are actively working on. Language ambiguity is a major challenge. Consider the sentence, "I saw the man with the telescope." Who has the telescope? Context understanding remains difficult for machines. Bias and fairness are crucial concerns. Models can perpetuate societal biases present in training data, leading to unfair outcomes. Multilingual and cross-cultural understanding is challenging, as most resources are available in English. Looking ahead, we're seeing exciting developments. Multimodal AI that combines text with images and audio, more efficient models that require less computational power, and better few-shot learning capabilities. The integration of NLP with other AI fields is creating new possibilities for artificial general intelligence. Wow, we've covered a lot of ground today. We explored what NLP is, understood the core concepts of NLU and NLG, walked through the typical NLP pipeline, looked at important tasks and techniques, and discussed the tools you can use to get started. If you found this video helpful, please give it a thumbs up and subscribe for more AI and machine learning content. In the comments below, let me know which NLP application excites you the most. In our next video, we'll dive deeper into building your first NLP project step by step. Don't forget to hit the notification bell so you don't miss it. Thanks for watching, and I'll see you in the next video. Keep learning and keep coding.